Okay, another example on two smooth spheres colliding. This one kind of involves vectors, and actually it's, if anything, a bit easier going. So we have smooth sphere A of mass 5 kilograms moving on a smooth horizontal surface with velocity 2I plus 3j. If I could encourage you all just to try and draw a reasonable sketch for these. It doesn't have to be perfect, but so across 2, up 3, and that's sphere A. I pretty much draw my worst sketch ever now. And then it's colliding with sphere B. They actually meet in with the line of centres parallel to the y-axis. If you read the example through. So this is A, 2, 3, mass 5 kilograms. And then it collides with B, and B is initially moving with velocity 4I minus 2j. And has mass 3 kilograms. So that's kind of the before collision. E is equal to 3/5. And then we want to find velocities of base spheres after the impact. And I'm going to take the up as being positive. No particular reason, but it just kind of makes sense because obviously up is positive with your vectors. So after collision, perpendicular to the line of centres, motion remains unchanged. So A will still be going right by 2, and B will still be going to the right by 4. They're coming together here. So with these questions, we tend to model them as going apart after collision. So I don't actually know what this is going to look like, but that's kind of the guess at the directions. The thing we do know is that coming across here is 2, 0, and coming across here we've got 4, 0. Might be better actually, so you can see it more, to put that in there as 4, 0. And then that one plus that one gives you the resultant on the hypotenuse. So similarly here, sphere A, sphere B, I'm going to label this one here as V and this one here as W. So we've done the perpendicular to line of centres here. So we've got the 4 and the 2, so motion remains unchanged. So parallel to line of centres. So we can think about momentum. So momentum before, I've got going upwards 5 times 3 plus 3 times minus 2, because this is heading in the negative direction. And that's going to equal 3W minus 5V. So we're assuming that what you've written here is positive. That simplifies down to give you 9 is equal to 3W minus 5V. So we're expecting some simultaneous equations. And then restitution, the approach speed parallel to the line of centres is 3 plus 2. So E times the approach speed is equal to the separation speed, which is v plus w. And 5 over 5 cancels off, so we end up with v plus w is equal to 3. And then you can either solve them by hand, you can just put them into a calculator, but you end up with w equals 3 and v equals 0 from there. So velocity of A will be 20, and velocity of B will be 4, 3. So we're going across 4 and up 3. So nothing too bad going on with that one. You can use IJ notation. I quite like column vectors, or mix and match.